Today we are talking about inverses and how to find them using an equation from a table and from our graph. So first, to find an inverse from an equation, we're going to switch the x and y. And once you do that, you're going to solve for y. Okay? To find an inverse from a table, you just switch the x and y values. Okay? To find an inverse from a graph, it ends up being a reflection over the line y equals x. Okay, and if you remember, y equals x is the parent function for linear, so it's the one that goes straight through the origin. If you don't know how to do that, then again, just take one of the coordinates on the graph and switch your x and y values and plot those points. So, example 1, I want to find the inverse, graph it, and determine if it's a function and the domain and range. So when you're doing the homework, you have to make sure that you read the directions carefully so you know exactly what it's asking for you to do. So first, I'm given this table. X, Y, I have 2, 3, 3, 4, 4, 5, and 5, 6. And the way we denote inverse is f to the negative 1, x. That's going to be our inverse sign. So that's an exponent of negative 1. Alright, so since it's from a table, if I go back up here, I'm just going to switch my x and y values. Okay, so I'm still going to have x, y, but instead of 2, 3, it's going to be 3, 2. Instead of 3, 4, it's going to be 4, 3, 4, 5, 5, 4, 5, 6, 6, 5. Okay, so there's our x and y values flipped. Alright, so now if we graph these, 1, 2, 3, okay, there's the first one. Alright, then if we graph 3, 2, 4, 3, 5, 6, 6, 5. Okay, there's the next one. Alright, that is a reflection over my line y equals x. So that right there, the dashed line is y equals x, and it's a direct reflection over it. Okay, is this reflection, so this is your inverse equation, and this one's your original. Is that a function? Well, then it passes the vertical line test, so yes, it's a function. And the next thing I need to do is I need to write the domain and range for both. So domain for the original. Okay, if I look, x values, they continue going to the left, continue going to the right, so it's all real numbers. Remember, those two things mean the same. Okay, range, same thing. Values going down, values going up. So again, all real numbers. And in general, most of the time, for our inverse, the domain and range just flip. Well, since these are the same, they're going to be the same here as well. So domain is negative infinity to infinity, range is negative infinity to infinity as well. All real numbers in both cases. Alright, so that is example number 1. Example 2. find the inverse, graph. So I'm doing the same thing that I did before. Determine if it's a function, and list the domain and range. So for this one, I'm given the equation to start off with, f of x equals 2x squared minus 2. Well, I know that f of x is the same thing as y. So if we go back up to the top where we're given an equation, I'm going to switch my x and y. So now this is going to become x equals 2y squared minus 2. So that's where we switch x and y. Okay, then we're going to solve for y. So in this case, to solve for y, I need to add 2. So I have x plus 2 equals 2y squared. Then I need to divide by 2. Okay, so now I have x plus 2 divided by 2 equals y squared. Okay, and you should know how to get rid of square root or squared. You take the square root. When you take the square root, it's plus or minus. So my inverse equation is the plus or minus of x plus 2 divided by 2. Alright, so there's our original function, there's our inverse function. Okay, if I were to use a calculator, let me grab one. And I plug in both of those equations. So I have 2x squared minus 2, and then I'm going to do the positive square root of x plus 2, and all of this is on the inside, so I need to put parentheses around the whole thing, divided by 2, and the negative. Okay, so if we graph, there's our original, the parabola, which you should know it's a parabola because it's squared. And there is our inverse function. Okay? So if I just make a sketch of that, we can go to the table to plot a few points. Ignore what I'm doing right now. Okay. So I have -1, 0, 0, -2, and 1, 0. So there's our parabola. Okay, and if I just take those and I flip them, so -1, 0 now becomes 0, -1. 1, 0 becomes 0, 1. And 0, -2 becomes -2, 0. So there's our function there, or our graph. Now, if I were to look at this, because of the vertical line test, it's not a function. Okay, it crosses more than one part. Alright, and then the domain, if we look at our original, the domain, if I look at this parabola, we have an arm going to the left, we have an arm going to the right, so that is all real numbers. Okay, if I look at the range, I don't have an arrow pointing down, but this is the lowest point. It's -2 to infinity. Okay, so then the inverse domain and range. So if I look, I'm looking at this sideways parabola now. Okay, my domain, I don't have an arrow pointing this direction. I start at -2 and go to infinity. And then the range, I have an arrow that's continuing, going to go down, continuing going up, is all real numbers. So if you look, in this case, our domain and range flipped as well. Alright, so we found the inverse, we graphed it, we determined if it was a function, and we found the domain and range. Alright, let's look at another example. Example 3. I have f of x equals the square root of x plus 7. And I want to find those same things again. This time I'm not going to actually graph it by hand. But again, that's your y. So I'm going to switch x and y. In order to get rid of a square root, you take this squared power. So then this becomes x squared equals y plus 7, because the square root cancels the squared. Okay, and then to solve for y, subtract 7. So my inverse function is equal to x squared minus 7. Now, if I were to graph both of these, so I'm going to clear those out from the last problem. I have the square root of x plus 7, and then I have x squared minus 7. Graph. Alright, so there's the original, and there is our inverse. Okay, I'm not going to actually graph those, but if we look, is this parabola a function? The answer to that is yes. So, yes, a function. And then I want to write the domain and range for both of those. And I'm going to do that by looking at the graph. So if we look at the original problem, which is just this little part right here, there's nothing to the left of this negative 7, and it continues to the right. So there's our domain, negative 7 to infinity. Now the range, there's nothing below 0, but it continues going up. So our range is 0 to infinity. Okay. Now for the inverse, I can't just switch these, because if I look at it, it doesn't have the exact same shape as the original problem. Okay, it's missing half of it. So for domain, both arms continue to go left and right, so that's all real numbers. And then the range, that's going to be like our domain from the original. It's negative 7 to infinity. So because our original problem didn't have this bottom piece, because it would not be a function if it did, then that's why we can't just switch our domain and range. Alright, one last one that I'm just going to solve, and that's about it. Find the inverse of this. So again, that's the same thing as y. We're going to flip our x and y's. Oops, that should be a minus still. Okay, so to solve for y, I'm going to add 1. So now I have x plus 1 equals 4y. Divide by 4. So the inverse function is x plus 1 over 4. And in your homework, on some of these, you'll just stop here. Some of those you'll graph. Some you'll have to write the domain and range. So that's why previous examples we did all of those. The assignment for this is A11, page 416, 4 through 28 evens, and 29 and 30. If you have any questions, please come see me, and good luck.